We're studying IGCSE Physics and we're revising light waves. Now, in the last class, let's recap what did we do. We looked at formulas, we looked at lenses, we looked at reflection. Now, today we're going to, today's agenda is to do past papers. Right, it's a practice class. First question
just
is,
one thing.
yes.
Can we just do lenses in a little bit more detail? Like spend half an hour on the recap and then half an hour on the past papers.
Fine, okay, we can do that. Let's start with lenses. Let's start with something else, actually, something new. I think we missed a few things. That is diffraction
Yeah,
and
I think.
dispersion.
And I don't think we've done the glass block experiment properly.
The glass block experiment.
Yeah, when you pass light through like a light ray through a glass block.
Okay, all right,
And then
all right.
we could just do a question about it. We could just do a
Diffraction.
question.
Yeah, we can do a question on that. Now, one more thing, electromagnetic spectrum. And everything on sound waves and everything on ultrasound. Let's start with diffraction. Now, what is diffraction? What is the meaning of this word? Now, I want you to write the definition in your notebook. Give the title, today's title, and write the agenda. These are all in the agenda. And diffraction. So what is diffraction? Diffraction basically means the bending of light when, or let's say into region of geometric shadow when passing or when passing through an aperture, a narrow aperture. That is the exact definition of diffraction. Now this is 2 marks in the exam. What are the exact words you need to write? Bending of light when passing through a narrow aperture. If you write these words, you'll get the marks. But I want you to mention this part as well, region of geometric shadow. And we'll see what that means in a second. Write this down, tell me when you're done, all three of you.
1 second.
Wait, just the definition of diffraction?
Yeah, definition of diffraction, that's 2 marks. After that, I'll tell you, how do we do diffraction?
Okay.
So instead of saying aperture, it would be better if you say gap. Over here. Slash aperture.
Okay.
Fine, next thing is, I'll make a few diagrams for you.
Okay, I'm done.
Done?
Yeah, done.
Okay, so now degree of diffraction. Let's say factors for diffraction. What are the factors that cause how much diffraction is going to happen? There are a few things. First thing is distance of, let's say, or width of gap. Second thing is wavelength. Now, most diffraction occurs when width of gap, or let's just say gap, is equals to wavelength. Now, this right here is a key point. This will be asked in the MCQ and the theory. Not so much in practical. We'll look at what they ask you in practical later. We'll start practical properly. Practical is not that much. After you finish all the topics in theory, that's when you can start practical. We'll do virtual practicals for all of that. Now, write this, tell me when you're done. Next thing is the diagrams. Let's make our waves. Now that is a wave that is coming in this direction, like this. Now what happens when it passes through a gap? Let's make ourselves a gap. Now right here, when you realize, let's say if I make a gap this big, now this distance right here is my wavelength. Now that's my wavelength. But this one right here is the gap, right? Now we realize the maximum diffraction happens when the gap is equal to wavelength, but this now, right now it's not. It's more than wavelength. So we'll just write gap is more than wavelength. And what happens when this is the case? Wavelength stands for lambda. Fine. Now what will happen if I do this? The waves are still going to pass through. Just a second. But they won't look like this. They'll look something like this. Is that clear? And then it continues going at the same height, and it becomes straight. That is what happens. Now, in this case, we realize that the bending or the curving of wave is not that much. It's almost flat. Right now, what happens if I take a gap which is even smaller? Let's look at that. Now, please make these diagrams in your notebook. If you have any questions, ask me. Let's look at the second case. Let's look at the second case. In this case, I'll make gap equal to wavelength.
Are we supposed to draw those?
Yes. This in the exam is 3 marks, Anas. What are the marks for? The marks are for that the wavelength cannot change. The wavelength do not change. All of these are the same wavelength.
So wait, can you explain once more?
I'll explain one more, sure. Now what happens is a wave is coming like this through this gap. Now we have, like, let's say a block or some kind of barrier which is making this gap right here. When the wave passes through it, this is how it curves. It does not curve much, it curves a little bit. It will make more sense when I show you the other diagram, okay? It's going to curve like this. Like this. The wave changes shape. So wave changes shape.
For example, when in movies, when the protagonist punches someone in the stomach and then they go.
Yeah, something like that. Now let's look at the other diagram. When the gap is equal to the wavelength. So I'll have to make a smaller gap. So the difference, the length between each wave, that's called the wavelength. And we have a gap through which the wave is passing. Now if I make the gap and the wavelength equal, okay, then this is what happens. Is that clear? Something like this. So there's a lot more curving happening here. Any questions? Look at both of these. The curvature increases a lot more than this one. Okay, it was very less curving only at the ends, but now when the gap is equal, the curving is so much, the whole wave is bent. Perhaps something like this. Now again, the gap between all of these must stay constant. The wavelength does not change, but only the wave curves. So wave curves more as smaller gap. Any question? Anas, Shrey, Ayan? Any questions?
Oh.
That's all that's happening. Now what happens if I have
What's equal gap?
yes. This is the equal gap. So case 1.
Wait, so after it curves, will it go back to normal? Like eventually go back to normal?
Eventually it will go back to normal. Yes, eventually. Now, after let's say a very long time, so you don't have to know, think about that.
Equal gap. I thought that was larger.
This is equal.
Okay.
Write case 1 and then case 2. Case 2 is when gap is equals to wavelength. Fine. There's one more case which is usually not asked in the exam, but I'll still tell you because I want you guys to score full marks. Gap is smaller than wavelength. Now, what is that? What happens then? If the gap is smaller than the wavelength, then you see even less diffraction.
Okay.
So the diffraction is not as much as you would see if the gap was equal.
So like
It was-
smaller waves?
Not smaller waves, it just bends. So the wave will come something like, it will become something like this. Similar to the other one.
After the fifth line or anytime?
Say that again.
Will it get curved after the fifth line or anytime?
It curves after passing through gap. Curves
Oh,
after gap.
so that's a gap, like Flappy Bird.
Yes. Like imagine, I'll show you a physical diagram, a physical picture in a second. But let's just say less curving right here. Less
So-
curve.
All right.
Over here, wave curves most. The case as lambda is equals to gap. Wave curves less. Bas, that's all. Now I'll show you a diagram in real life. Now quickly copy this. Don't ask me questions right now. Ask questions. Write all of this down first. Ask me questions. That's okay. No worries. But we'll have to do questions, and that's when you'll understand in reality. Look at this image right here.
Write down.
Guys, can you see this?
Yes, sir.
Yes.
Now it's like an ocean, but you have this gap here. Imagine this as your gap. Okay? And you have these water waves coming here. And when they pass through this gap, they turn like this. Can you see that? I hope that makes it more easier for you to understand. Any questions?
No, sir.
No, sir.
Fine. That's the real diagram in real life. Now make these diagrams. Tell me when you're done. The next thing we have to look at is dispersion of light. Quickly write everything down. All of this is important. Okay, yep. This dispersion is quite easy. So take your time, write it down, tell me when you're done.
Yep, I'm done with the
Done,
drawing
alright.
and the writing, and I will be taking a print of this as well. It's
Perfect.
very, yeah.
Now, if you have any questions, ask me.
These are-
Done, sir.
Anas, done?
Yeah, almost.
So,
Yes,
is
sure.
there a difference in like the angles or something like that in
Okay, I
case
forgot
one
to
and case
mention that.
three?
Yes, exactly. No difference in angle, but I'll show you how to solve past paper questions. Okay, we'll look at that in a second. Now,
Okay.
there's a method, there's a trick to it. The way I solved it. Now, I don't think any of my friends did it that way, But since nobody scored more than me in class, so the method, I'll teach you the method, and you have to follow the method as well, hopefully. Now, so it will make things easy. You look at that when the past papers come, remind me to tell you the trick. Well, that's it. Because the marks are not just for the curving, but also for this wavelength. They should be equal. If you change this, you're losing 2 marks or 1 mark at least. Fine, that's it. Now, the region of geometrical shadow, what does that mean? I told you right here, the region of geometrical shadow, this point, right? The region of geometrical shadow. This is like, fine. Now, the region of geometric shadow is something like this. When you pass through, the wave must look something like this. Okay? The waves must be something like this. So my drawings are not perfect over here. It should look like this. Okay? So remove the extra parts over there. Now you don't have to do this right now. Don't do it. We'll look at this afterwards. Now the next thing is to look at something called dispersion of light in a prism. I'll show you in a diagram. First diagram is this one right here. Now, all you need to memorize in this is that dispersion of light. Write this down. Okay, write the few things down. Dispersion occurs in a prism due to refraction. Different wavelength of light bend at, let's say, 2 different degrees, or let's say bent differently to different extent. That's all you need to know. If they ask you how diffraction occurs, you need to know that it occurs due to refraction. Dispersion occurs due to refraction. Dispersion is basically refraction in a prism. So this light comes in like this, and then what happens is the light wave it causes a refraction, and all the different wavelengths of light separate based on their speed, based on their wavelength. Now we realize that when the wave goes inside, it bends, and it does bend, but the amount of bending depends on what the wavelength is. So let's see what happens. This is how the original wave should look like, but it does not look like this. It looks kind of different. This is the original light. Then we have red light here. Then we have purple light here. Let's make a new diagram actually. Perfect. Okay. Now this is your original light going something like this. The first one is
Just
going to
one
be red.
question.
Ask me.
Why is it starlight from telescope?
Well, because light coming from a very far distance. It could be anything. Doesn't have to be star. It could be sunlight.
It can just be a normal light ray, right?
Right? Sunlight, bulb, let's say LED, anything. Doesn't make a difference.
Okay, fine.
Now you have light coming like this. Okay. That's red. But the purple light, violet, will diffract in a lot more than this. And in the middle, you'll have blue, or let's say not blue, green. Green, right here. So we realize that red diffracts least. Let's write it down. Features of dispersion. Red light diffracts least. 2.
Do we draw
Violet.
that prism?
Yes. No, you don't have to draw it. No. Write this down only. Okay. You can draw it, but I would not prefer, don't draw it. Now, just write this down. Red light refracts / bends least. Violet light bends / refracts most. That's all you need to know here. Okay. And green is always in the middle.
The red light refracts, then the violet light will bend.
No, not like that. It's the same thing. So bend and refract means the same thing. Is that clear?
Oh,
Fine. Bend and refract means the same thing. Bend or refracts or bends least or bend least. I'll tell you if you have to think like that, but in this case, refract and bends mean the same thing. In the question, they can say both the things. Okay. Now, from this, we realize something called one more thing, by the way. Yes, Shreya, can you hear me?
I can.
This cannot be fine. Okay, so this is light. Okay, light.
It's just like
Now what you're receiving over here, this right here is called monochromatic light or light of. Do you know what this means? Ayan, what does it mean?
It's the light of it's light of one single color. There's no
One single
other
color,
color
exactly.
in it.
Exactly. So monochromatic
I know
light,
that
write the
from
definition.
art, yeah.
Monochromatic light is light wave with a single color, or let's just say not single color, single wavelength / which also means and color. So the key word is wavelength, not color. Color is because of the wavelength.
Okay.
Write all of this down. Tell me when you're done. Write this as well. One more thing, in this dispersion of prism, write the third point. Spectrum of light, or when white light enters, a spectrum.
White light enters a spectrum of monochromatic light leaves, right?
Yes, is observed. Is that clear?
Yes. Okay, can you zoom out?
Yep.
Yes, perfect.
Now, one last thing, I'll give you the spectrum right here, which you need to memorize by heart. Spectrum.
Oh, it's
The
this
spectrum
video
is
or like Roy
Gibbon. Right, Roy Gibbon. Or Webcure. Your choice.
Yes.
Now, you have to write this. One thing you need to write is red has the least or most wavelength
Oh yeah,
or
that's yeah.
and least frequency. Violet has least wavelength
Least wavelength, most
and
frequency. Yep.
most frequency. Webcure.
Okay. Yes, if you could just remove that toolbar up there.
Better?
Yes, perfect. 1 second. I'll take a screenshot and then write it.
Anas, any questions? Ayan, any questions?
no.
Okay,
No,
fine,
sir.
fine. I'll give you one more spectrum. Since we're doing spectrum, right after this, we'll finish this first and tell me when you're done. The next thing I'm going to give you is called the electromagnetic spectrum. It's not related to this at all. It's completely
It's
different.
not in light though.
What is
It's
spectrum?
just waves, yeah?
Yes, electromagnetic waves.
Yes, perfect.
I'll also give you a question meanwhile. While you're writing, I'll look up a question and we'll look at dispersion. Right here.
Wait,
Okay, yeah,
so,
perfect.
I have most wavelength and less
Least frequency,
east,
lowest
less
frequency.
frequency.
Okay, now write this equation, all of you. V is equals to F lambda. V is always 2 into 10 raised power, not 2, 3 into 10 raised power 8 meters per second for all electromagnetic waves,
Yeah.
including light. So
Mhm.
don't think that radio waves are slow compared to light waves. They are the same speed.
Mhm.
Unless any questions?
Yeah, what is spectrum?
Spectrum means like when you go to a shop and the shopkeeper gives you like 5 options or 10 options. Like he has, okay, look at all of these spectrum of products. That's what it means. It means basically many different options, or let's
Okay.
say different uh, categories. Okay. Over here we have 7 categories. Red, we have violet, indigo, blue, green, yellow, orange, red. That is also what makes up a rainbow. So in some way, this is a rainbow right here. They won't ask you this in exam, but the same thing happens because in rain, the same thing happens. I've gotten the question for you. So write this, tell me when you're done. Now look at this word over here, Shrey, not Shrey, Anas. Read this
Okay.
definition out loud.
Wait, I don't see it.
Monochromatic light. This one.
Oh, monochromatic light. Light wave with a single wavelength, frequency, and color.
So wavelength and frequency. Look, if wavelength is single, then frequency will also be single. So you can write both wavelength or frequency. In the question, they'll also say wavelength or frequency. So light wave with a single wavelength or frequency and color is basically monochromatic light. So write this over here. Now tell me when you're done, and we'll look at the past paper question.
Wait, we rewrite the definition for that?
Yes, Anas?
Do we rewrite the monochromatic
Yes,
definition?
rewrite it and add the word frequency. There's only one thing I added. I added frequency over there. Okay. So after wavelength, put like an arrow like this and say or frequency.
Done.
Done. Ayan, Anas, Shreya, done.
Give me a second.
Okay.
Done, sir.
All right.
Okay,
I
done.
mean, done. Okay. Look at this question. Now, Anas, Ayan, I think if you're feeling sick, then Shreya, read the question.
Okay. 7A. Figure 7.1 shows a ray of blue light shining onto a glass prism. The figure and then With the aid of a straight edge, draw a possible path of the ray through the prism and into the air until it reaches the screen. When
Blue light.
B.
Okay.
Yeah,
Yeah.
okay, fine.
Now we have to solve this question. 3 marks. 3 marks.
Uh-huh.
And they're
If
asking
we
us
didn't
to.
know
Yes.
that monochromatic light doesn't disperse, then I'd probably have done like the whole dispersion thing.
Okay, sure. Okay. Now, all of you, I want you to draw your answers on the screen with your, however it looks, right? Draw it on the screen.
Okay.
I'll tell you if it's correct or wrong.
The normal. Mhm. Give me a second. Um,
You can also do it on your notebook if you're not able to draw. You have 30 seconds.
no, that's yeah. Well, I don't. The thing is, I don't remember the denser and
Okay, let's do it right now
yeah.
then. Fine. Now, all of you, Anas, I want you to read the question one more time. Read it, Anas.
Okay. With the aid of a straight edge, draw a possible path of the ray through the prism and into the air until it reaches the screen.
Through the prism, into the air. And what kind of light is this? This is blue light. Fine. Now we know from here that blue light or purple, blue purple, is going to bend the most. This is blue and purple. This is red, orange, yellow, green in the middle. So what we realize is that purple, blue, all of this bends the most. Now you need to realize that monochromatic light does bend, because over here what's happening is you're getting like a mixture. You're getting red, you're getting blue, you're getting green, all of these colors, but they are mixed together so they look white. If you mix all of
Okay,
these, they look white.
I've got
Right?
the answer. Can I draw it on the board now?
Not now. I'll show you the answer. We have to hurry up. You can draw it in a second, just a second. Now, this is what the waves look like. It's coming like this. And then
Mhm.
all of these waves bend differently. That is what happens. Monochromatic light does bend. Let's go over here. Now we realize you have blue light. So blue light does bend the most. So it will bend something like this. It won't bend like this. That's not going to happen. It must always
Yeah,
be
like
on the
that.
other side of the normal. This is the normal,
Yes.
like that. Now one more thing will happen. Look, when you have blue light coming like this, it's going to bend. Fine, a lot. Let's just make it too much, like this much. Fine. But the issue is what happens after it reaches this air. It will bend
Oh,
again because I have to make a new normal,
yeah.
and it will again bend. Just a second. Just it will again bend like this. Is that clear?
It's
Any
going into
question?
the air, right? So
Yes,
it's going to be towards the normal. Sorry,
away
away
from
from
the
the
normal,
normal.
and that is
Away
what
from the
happens. Look,
normal.
that's what happens. Theta, let's say theta I and theta r. Theta r is more than theta I. That means it's bending away from normal.
Okay,
Okay,
fine.
so
Yeah.
it's towards normal inside and then away from normal. Towards normal, then
Mhm.
away from normal. Anas, any
Mhm.
questions? Why is it away from normal? Because look, at first what's happening is this is going from less dense, air is less dense to more dense, back to less dense. When you go from less dense to more dense, it's going to bend towards the normal. Again, less dense to more dense to less dense, it bends away from normal. And that is what you get. So the light will reach till here. We can remove the extra part from here. That's it. That's all you have to draw. Is that clear? Any questions? Anas, Ayan, any questions?
No.
No, sir.
Let's now read the question, Shrey.
Okay, 1 second. With the aid of a straight edge, okay, we're done with that. When a ray of white light passes through the prism, it spreads into a spectrum of colors that can be seen on the screen.
Anas,
What is the
continue.
name? Yeah, okay.
Quick, Anas, hurry up.
Okay, what is the name of the spreading effect? Take one box.
What is the name of the spreading effect? Tell me. Reflection,
Dis-
convergence,
I think
disperse.
dispersion.
okay.
Now, two answers. Write it in the chart. Which color is deviated least, deviated most? I need 3 answers in the chat from all of you. Well, 2 answers and 3 people, so 6 answers. Yep, got 2 answers correct. And perfect. See, so you guys understand now, right? I hope you're learning something.
Yes,
That's
we
it.
are. Who gave the
Wait,
answer?
mine is correct.
For the
Yes,
sake.
all of you are correct.
No,
Good.
who
Now
gave it
electromagnetic
first,
waves.
though?
Now this one is, who gave it first? I think it was Shrey. So Shrey gets double the points. Let's just keep a track of the points here. Shrey, Ayan, and Anas. A-Y-A-N. Shrey is 2, this is 1-1. The electromagnetic waves. It has a spectrum. I think I've given you a diagram, but write this in your notebook. Rugby match is very unlike. If you have checked your corrected papers, I think you should have found it there. Is very unlike xylophone game.
Oh, yeah, I think I read it somewhere and then forgot about it. Wait.
Forgot about it. Now you should not forget about it. I think it should be in your corrected paper. Now I'll show you the actual diagram in a second. Electromagnetic waves and the spectrum of waves. We're doing spectrum of EM waves.
What does this mean?
Just give me 1 second. I'm showing you.
Mnemonic.
Okay, give me 1 second. I'm answering a call.
Oh, okay.
Now write it down. This is called a mnemonic. I hope that's the correct word. Nick. Short form. Write it first. I'm showing you a diagram. The diagram is that doesn't look good, does it? Okay. Now you have to memorize this. This number right here. The wavelength. First thing is the kind of waves we have. Look. So when you look at this right here, you have the first one is called radio. Radio waves, that's for rugby. Microwave is for match. Infrared is for is. Visible light is very. Ultraviolet, unlike. X-ray, then gamma ray. Now this is like 3 marks in the exam. This is for 3 marks. If you can give the names properly. After that, we have a number right here. It's like a phone number. You can memorize it. 3256 81012. This is for the wavelength. Any questions?
Wait, all of
Now-
them are negative, right?
Not all. First one is positive. The rest are negative.
Okay. So, yeah, fine.
If you get a question like this, let's say, guess the wavelength of radio wave. Okay, guess. Question is wavelength of radio wave.
Mm-hmm.
Okay. and you get a few options: A, B, C, and D. Now the first one, let's say, is 1 into 10 to the power 3. Let's say this, or let's just say this is 1000, and this one is 0.5, this is 0.005, and this one is 50 meters.
Okay.
All of these are meters, by the way. Now what happens is, which option are you going to choose? Let's just convert this into standard form.
A.
It's obvious, but what if you had visible light as an option? Okay, let's change this. Let's say visible light.
Wait, how do you know it's A?
I'll tell you in just a second. Let's do it for visible light.
All right.
Right?
Right.
Let's say 0.00005 meters. Now, how do I know which of these is the correct option? First one is going to be 1 into 10 to the power 3. Next one is 0, or let's say 5 into 10 raised to the power minus 1. Next one is 5 into 10 raised to the power minus 6. Last is 5 into 10 raised to the power 2. Now, which of these do you think is the closest to visible light? Visible light must be 10 raised to the power minus 6. Which of these is 10 raised to the power minus 6? Anas, tell me.
Visible.
No, that's visible, but which of these options? A, B, C, or D?
Okay, 1 second. 10 to the power 6. It's not.
See right here, look.
Oh, we
This one.
multiplied by 5. Okay. 5.
10 raised to the power minus 6. This is the number that matters. Now, this one does not matter. It could be 9, it could be 10. It does not make a difference.
Okay, it's 6.
So 10 to the minus 6, that's the correct option for visible light. In the same way, in the exam, just convert it to standard form. Then from this list of, you need to remember this, whichever is closest to the one they're asking must be the correct option. Is that clear? Any questions?
No.
Now, what do you have to write? You have to write this. You need to write this part, and this part. Right now, tell me when you're done.
I still didn't understand what rugby match is. Very unlike.
Now look. Rugby stands for radio, R. You see, M stands for match, I stands for is. Now it may be difficult for you to memorize this one, but I think it's easier for you to memorize this. V stands for visible, U for unlike. Does that make sense, Anas? The first letters are the same.
Okay.
So it will help you understand the order of these. You must write them in the correct order in the exam. So microwave comes after radio wave, infrared comes between visible and microwave, right? So rugby match is very unlike cell phone game. Write this down, tell me when you're done. Anas, any questions? Ayan, any questions? Shrek, questions?
No question.
No, sir.
No
All right.
questions. It's pretty easy.
Hurry up, and the questions are not easy, right? That's the case. So you have to apply all of this knowledge into a practical sense. That's where the questions come in. Because if you don't solve past paper papers or past paper questions, you will not be able to solve the actual papers in the exam. I hope I can give you a better diagram. And by the way, how do you find the frequency? Again, V is equals to F lambda. Okay, V is F lambda. So V is always 3 into 10 to the power 3 into 10 to the power 8. So you can find frequency by memorizing the wavelength. You understand how? Just plug in the wavelength. Let's say for radio wave, it's going to be V divided by 10 raised to the power 3 is the frequency. Or V is equals to frequency into 10 raised to the power 3, which will be 3 into 10 raised to the power 8 divided by 10 raised to power 3 is equal to frequency. And also share your contact in the chat for the others. Shreya, can you hear me? Shreya, Ayan, guys, mic on, quick.
Yeah, we can hear you.
Now, I want you to, after the class, I want you to send your corrected paper, which I corrected for you, to the other students in your batch, right? In the university, not the university batch, the coaching batch, right? So you have,
Yes.
so Shreya, send your paper to Anas, Ayan, Manvi, not Manvi, she's not in physics, and Neha. Ayan, send it to Anas and the others, right?
Okay. So we have an exam on Tuesday, right? So
Yes.
can we just send it on the group after you make the group tomorrow?
The thing is, I'm quite busy, and that is why
Do you want
I
me
don't
to
think
make
that's okay.
the group?
Not really, not right now. There are a few things we need to figure out first to make sure you're secure in the group. Okay. If everything is fine, we'll make the group.
I can't do it. I have to study for physics.
I don't. So I just want you to write this down on the board right now. Tell me when you're done. So focus on the board. Or instead of this, just let's say write one extra part here. Let's remove all of this for a second. To find frequency, use wavelength and formula. The formula is V equals F lambda. And all you have to do is replace the lambda with 10 raised to power 3. Example, for let's say UV light, 3 into 10 raised to power 8 is equal to frequency into 10 raised to power minus 8. Therefore, frequency is equal to 3 into 10 raised to power 8 divided by 10 raised to power minus 8, which will give us 3 into 10 raised to power 16 hertz. So whichever in the options is closest to 10 raised to power 16, choose that. Now write this as well.
Okay.
Ayan, how much have you finished?
Start with the question.
And now the question, this part. You have to write the names, the short form, and the wavelength.
I'm
Have you
writing
finished
the
writing
number.
it?
I'm writing the
Write
number.
them. And write this part as well to find frequency. Anas, how much have you written?
I wrote. I'm still writing the part you just wrote. I wrote until like the rugby match is very unlike the xylophone.
Okay.
Yeah.
Now hurry up.
Wait, does that say V equals Fx?
F lambda. This is lambda. Anas, what is lambda?
The wavelength.
Yes. Good. Good. The next thing we need to focus on is also light wave is done. We look at lenses one more time. We have to look at electromagnetic waves. We have to look at sound. All of that is remaining for revision. Okay, this is a good drawing diagram. It has everything here. Please take a screenshot of this. It also tells you the frequency with the wavelength.
Done.
Done. Okay, now let's look at the next thing. The next thing is, or before you look at that, I want you to do one more small thing. Take a screenshot of this as well. Now this diagram right here is going to tell you what are the uses. These are all the uses of each of these. Uses of EM waves. Any questions?
Wait, can you write it like types of electromagnetic radiation, and next to that with the parentheses, can you write uses of EM waves?
Now you just have to take a screenshot of this. The uses are broadcast, radio and television, used in cooking, radar, telephone signals. Infrared is for transmitting heat from sun, fire, radiators. Ultraviolet is absorbed by skin, and fluorescent tube, that is important. I'll do one thing. I'll underline the main key parts here. Radio, television, used in cooking, telephone, radar. You have transmit heat from sun, fire, radiator. Absorb a fluorescent tube for this. X-rays is to view inside of objects and everything. And gamma rays for medicine, for killing cancer cells. All of this is important. So take a screenshot. And I'm giving you some questions as homework.
Can you just scroll up once?
Yes, okay. Which part?
Yeah, the first image. I don't think I got a clear screenshot. One sec. Can you zoom in?
Okay. Yes.
Yes, thank you. One sec. And yeah, that should work. Okay, thank you.
Fine. Now just a second. I am taking the screenshot of this as well, the uses. But I think
Yes,
you
sir.
know it. Now finally, you have one question. This one.
Okay, then the process. That's different. Wait,
Now
I have a
I want you to do one thing. Yeah, ask me.
it says A part 2 says suggests the cause of the reduced spacing of the wave fronts to the right of the barrier. So do the spacings of the wave fronts, which is basically the wavelength, reduce in the process?
Okay, now the thing is, what we need to say here is that the waves are bending. That causes the spacing. Fine.
Okay, fine.
I'll show you. Now I hope to do questions. So I think if you're free later, perhaps in the next class, we'll do more questions on this. Just a
Okay.
second.
Also,
This one.
I
Okay, yeah, this one. Look, the cause is waves change speed. And we realize it's going from change
it's just
speed.
a water wave. It's not going through mediums.
No, but they're saying something here. Look. It has to be something on it. Now we'll talk about this in the next class then, fine?
Okay,
Because
fine.
we can only do so much. I hope you learned or revised something in this class. Please memorize whatever I've told you because those are the main key things. Fine, they're guaranteed to come in the exam.
Okay.
That's all for
Thank you.
today. Take care. Goodbye.
Thank you. Bye.
Zahra,
Goodbye,
can you
sir.
hear
Take
me?
care.
Goodbye, Ayan. Get well soon. Anas,
Good afternoon, sir.
show solve papers now and send me if you have any doubts. Fine.
Okay.
Bye. Goodbye. Allah Hafiz. Assalamu alaikum, Zahra. Can you hear me?
Yes, sir. Welcome, sir.
Okay. Now, what class do we have?
English.
English. Okay. So in the last class, we looked at a few things, right? Now let's look at the main things here. Other people are missing. Why are they missing in class? Now you're here. Where's Safa? Niranjana?
She's getting ready to join.
All right. Okay. I think the team did not send a message. Zara, did you get a reminder for the today's class?
So,
No. Oh, okay. I see why you did not. Because the
Wait,
timing has been changed.
can I get the past papers like for 2022, May, June?
Anas, I'll send it after class, right?
Oh, okay.
Now, if you want, you can also buy the booklet for the yearly partial booklet. It's cheaper. It has all the past papers till 2022. You can also ask the team for that.
Yes, okay.
Fine.
All right. Bye.
Take care. Now, good luck for your exam. Next thing is, what are we doing today? We have English. Now, I'll just write a few things down. The main things are that we have to look at summary, right? We have to look at note making.